Hey guys, today we're going to be solving quadratics by using the square root. Okay, so first thing that we kind of need to talk about is, well, how do you do square roots, right? Obviously it's a feature that you do find in your calculator. So when I take the square root of 25, okay, it basically means what are the two numbers that multiply to it that are the same, okay? And that would be 5. Now here's something special about square roots. When you take the square root of a number, you have two options. It can be a positive 5 or a negative 5. Okay, so really the answers for what are the square roots of 25 are 5 and negative 5. Alright, what about for 36? We would get plus or minus 6, which basically means positive 6 and negative 6 are the square roots of 36. 49. It would be plus or minus 7, which basically means that I have a positive 7 and it could be a negative 7. 0. Well, the square root of 0 is pretty simple. It's going to just be 0. Now notice there's no plus or minus needed because 0 isn't positive or it cannot be negative. For right now in Algebra 1, whenever we have a negative value that we have to take the square root of, we're going to put that there is no solution. Okay, so you cannot take the square root of a negative number for this. Quadratics can have either no solutions, one solution, or two solutions. So to get no solution, okay, it's when your x squared equals a negative number. Okay, because remember, the square root of a negative number is not a real number. That's something you'll learn more in Algebra 2. To get a one solution, okay, the situation is that you'll have x squared equals 0, because you just learned that the square root of 0 is always 0. How you can end up with two solutions is when your x squared equals a positive number. Okay, then the square root of a positive can be either the positive answer or the negative answer or number. Okay. One thing I do want you guys to recognize is you can use this method only when you have y equals ax squared plus c, which basically means that the bx is missing. Alright, it's not really going to be possible for you to do the square root concept if there is the bx there. Okay, so just food for thought. So example 1, using square roots, we're going to solve 3x squared minus 75 equals 0. And we're actually going to take this back to our concept of how to solve for a variable, okay? Because ultimately we're trying to get the letter x by itself. So notice that's why I have the three letters over here, B, C, D. Hopefully we remember what they stand for. B stands for box your variable. C stands for cancel what's beside your box. And remember, you do that by either adding or subtracting. And finally, D stands for divide by the number inside your box. So let's follow our steps here. First, I'm going to box my variable, which is the 3x squared. I notice that I have a minus 75 next to it, so I'm going to cancel it by making it a plus 75. What you do to one side, you know you got to do to the other. Bring down my box. We canceled what's beside it. 0 plus 75 is 75. Cancel what's beside it. Last step, D for divide by the number inside my box. So we end up with x squared equals 25. Now we can't end here because x is technically not by itself. So the last step, okay, anytime you have a squared, is you just take the square root of both sides. Now when you take the square root of something that's squared, that squared cancels out and all you get is what's on the inside, which is x, equals, remember, the square root of 25, our answer is going to be a plus or minus 5. So I can say that the answer is that x equals 5 and x equals negative 5. Applying quadratic equations. So let's say a museum is planning an exhibit that will contain a large globe. The surface area of the globe will be 315 feet squared. Find the radius of the sphere. Use the equation S equals 4 pi r squared, where S is the surface area and r is the radius. Notice they give us one piece of information that we need, and that's that the surface area is 315. So I can actually rewrite this equation, 315 equals 4 pi r squared. Now I can continue with my steps. B for box my variable. Now technically, if I draw a box around here, notice, is there anything next to it to cancel? No. So notice I really didn't even have to draw the box in this situation. What I'm trying to solve for is for that r. Okay, so I go straight to D, which stands for divide. Okay, and there's two things I'm dividing by, the 4 and the pi. 4 pi. Now, we're not going to use 3.14, even though we can if it says that. Alright, so when I work this out, we actually get 247.4. So that's 315 divided by 4 pi. The answer is 247.4. And we cancel out our 4 and our pi, and we're left with r squared. Now, remember, you're not done because you have to get rid of the squared by taking the square root of both sides. So that cancels out the squared part. We bring down our r equals, the square root of this is going to be plus or minus 15.7. And notice it's an approximation, okay, so it's approximately this. Now, here's one thing that we have to think about. Can a radius, right, can a length of something ever be a negative value? No, it cannot. So, our only answer then is going to be 15.7, and we'll round that up to 16. So the radius of the sphere is about 16 feet. Next problem. X plus 7 squared equals 100. Now, this problem is a little different from the previous two problems because I notice that my exponent is on the outside of the parentheses. So before I can box my variable, cancel what's beside it, and divide, I actually have to deal with that squared. Now, remember what we talked about. In order to get rid of the squared, all I have to do is take the square root of both sides. So what I end up with is, when I take the square root of that, I know I get rid of the squared, so I bring down the x plus 7 equals, now remember here, when you take the square root of 100, it's going to be a plus or minus 10. So basically, I can actually turn this into two problems. I have x plus 7 equals 10, and I would have x plus 7 equals negative 10. Alright, well, now we can follow our three steps. Box my variable, cancel what's beside it, x equals 3. Notice there's no need to divide because there's nothing with x except for 1, and that's always. Now I got to do the second problem. Same exact concept. Box my variable, subtract 7 to both sides, x equals negative 17. So there are two solutions for this problem. Number 4, okay, same concept. First thing I do is box my variable, cancel what's beside it. I cancel a positive 32 by subtracting 32. We get 2g squared equals 0 minus 32 is negative 32. Last step, D for divide, and divide by 2 because that's the number inside the box. I get g squared equals negative 16. Now, remember, when I take the square root of both sides, can we take the square root of a negative? No. So the answer then is no solution. Number 6, same concept. Notice there's no real need for me to box my variable, right? Because there's nothing next to it to cancel. So I'll go straight to the next step. D for divide. Divide both sides by 4, because that would be the number inside my box. X squared equals negative 25. Not done. Got to get rid of the squared sign by taking the square root of both sides. But notice, once again, it's negative 25. I can't take the square root of negative 25, so therefore the answer then is simply just no solution. Next problem. 2x squared plus 6x minus 72 equals 6x. Okay, notice it's a lot going on here, and we have to first, I notice, combine like terms because I have a 6x and a 6x on both sides. So let's go ahead and deal with that part first. So I'm going to subtract 6x. Notice I bring down the 2x squared. I notice that the 6x plus the negative 6x cancels out. I bring down the negative 72 equals, again, 6x minus 6 cancels out. I can't have nothing there, so I put 0 because that's what 6 minus 6 is, 0. So now I can actually work this out as before. First thing I do is box my variable. Notice there's only one variable, so that always makes it easy. I'm going to now cancel what's beside it by adding 72 to both sides. So we end up with 2x squared equals 72. D stands for divide by the number inside our box, which is 2. And we end up with x squared equals 36. Not done, because you got to get rid of the squared. I get rid of the squared by taking the square root of both sides. So that cancels out the squared. So x equals, remember, taking the square root of a positive number, I get two solutions, plus or minus square root of 36 is 6. So I can also write my answer. You can leave your answer like this, or you can say x equals 6 and x equals negative 6. I'll leave that up to you. Either way is acceptable. 3x squared plus x plus 3. I do notice that this is in our standard form, ax squared plus bx plus c. And I notice that there's this bx part there. So if that is there, then technically I cannot use the square root method to work out this problem. So this is a problem that we cannot do, okay, because it has that bx. We would have to use a different method, which you'll learn about later on. So let's go ahead and jump over to number 9. Notice the squared is on the outside of the parentheses. That means we have to deal with it first before we can follow our BCD. So I get rid of that squared by taking the square root of everything. So we end up with x minus 4 equals, taking the square root of 49, which is positive, so I get plus or minus 7. Remember, write your problem as two different problems. I have x minus 4 equals positive 7, and I would also have x minus 4 equals a negative 7. Now you can follow your steps. First thing I do is box my variable. C, cancel what's beside it by adding 4 to both sides. We get x equals 11. Notice I don't have to divide because there's nothing next to it to divide. Next one, same concept. First I box my variable. I would add 4 to both sides, and we get that x equals negative 3. So there's our two solutions for that problem. I want you guys to try this on your own. Okay, so you might want to pause the video, try it on your own. I will go ahead and work them out so that way you can check to see if you did it right. Just be honest, make sure you guys actually do take the time and try to do this on your own, okay? So you can already see that I worked out A, so hopefully that's what you got. You got positive 5 and negative 5. Notice I started working out B, and I noticed something interesting that I wanted to remind you guys of. Okay, notice that I get 3n squared equals 0. Technically, the next step would be to divide both sides by 3. So you end up with n squared equals 0. Now, here's where you got to be careful, because what did we learn when you take the square root of 0? How many solutions would we end up with? hopefully you said just 1, because we don't have a positive or negative 0. There's no such thing. So the answer is just 0. We end up with only 1 solution. Just wanted to point that out. Hopefully some of you guys already saw that. Now, remember, pause the video, finish up on number or on C. So the answer for C, remember you had to take the square root from the beginning in order to get x minus 11 equals a plus or minus 9. Notice I rewrote it as in 2 problems, and then the answers were that x equals 20 and x equals 2. Last problem, a city is planning a circular fountain. The depth of the fountain will be 3 feet. The maximum volume will be 1,800 feet cubed. Find the radius of the fountain using the equation V equals pi r squared h, where V is the volume and r is the radius and h is the depth. Notice they give us some valuable information already to fill into that formula. They tell me that the height is 3 and that the volume is 1,800. So I went ahead and plugged that into our formula. So our new equation is now 1,800 equals 3 pi r squared. This looks like just the previous problem we did, or the second problem we did in these notes. So now what we need to do is BCD, okay? Notice technically I don't need to box my variable because there's nothing next to this box if I was to draw it. Okay, there's nothing next to it to cancel. So I go straight then to the last step, which is to D, divide. And I'm going to divide by 2 things because there's 2 numbers or 2 values next to R, and that's 3 and pi. Alright, so 1,800 divided by 3 pi gives you 18.87 is approximately what our R squared is. To get rid of the squared, we have to take the square root of it. So when you do that, our answer is going to be approximately 41.5 is our R value. Now remember, technically that's a plus or minus, and remember what we talked about. Can a radius, can a length be a negative value? No, it can't. So therefore our radius, okay, is going to be approximately 41.5 feet long. Hopefully this isn't too difficult for you guys. See you guys in class.